The morning of June 11th, 1943, and Oberst Nikolaus Ritter stands in a windowless laboratory deep inside the Zeiss Optical Works facility in Jena, Germany. In his hands, carefully reconstructed from memory and smuggled blueprints, sits what American military planners consider the most closely guarded secret of the entire war. The Norden Bombsight. 217 individual components arranged in a mechanical computer so sophisticated that each unit costs $8,800 to manufacture, more than some fighter aircraft, more than 3 years of wages for an average American factory worker. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Ritter has been waiting 5 years for this moment. 5 years since Hermann Lang, a German immigrant working as an inspector at the Norden Corporation factory in Manhattan, first copied classified blueprints in his kitchen while his family slept upstairs. 5 years since those plans, hidden inside a wooden umbrella casing, crossed the Atlantic aboard the SS Reliance. 5 years since Lang himself travelled to Germany on what he called a vacation, received 10,000 Reichsmarks, and spent weeks with Luftwaffe technical experts reconstructing every detail of America's billion-dollar precision bombing system. Now, finally, Ritter examines the prototype his engineers have built from Lang's intelligence. The device sits on a steel workbench, its gyroscopes exposed, its optical system gleaming under laboratory lights. It represents everything American strategic bombing doctrine promises: precision targeting from altitudes where German fighters struggle to climb, accuracy measured in feet rather than hundreds of yards, the ability to destroy a single factory, a specific bridge, a particular power station without wasting ordnance on empty fields or residential districts. The Norden consists of 2 primary assemblies: the stabilization platform on the left, a maze of gyroscopes that keeps the entire system level, regardless of aircraft movement; the sight head and mechanical calculator on the right, where the bombardier actually aims and releases weapons. Together, these components promise to solve problems that have plagued aerial bombardment since 1914. How to account for wind drift. How to calculate the precise moment of release when bombing from moving aircraft at varying altitudes. How to hit what you're actually aiming at. Ritter turns the adjustment knobs, watching internal mechanisms shift and recalibrate. The device is undeniably impressive, ingenious, even. American engineers have created something genuinely sophisticated, a mechanical marvel that represents thousands of hours of development and testing. But as Ritter continues his examination, comparing the Norden prototype to the Luftwaffe 7 bombsight that Carl Zeiss developed for the Luftwaffe, a realization crystallizes that will shape German defensive doctrine for the remainder of the war. The Americans, Ritter concludes, have built the wrong weapon, not wrong in principle. The Norden's tachometric design, using gyroscopic stabilization and continuous recalculation of bomb trajectories, is sound, technically brilliant, in fact, but wrong for the reality of strategic warfare, wrong for mass production under wartime conditions, wrong for the actual challenges bombardiers face at 25,000 feet over defended targets. The complexity that makes the Norden theoretically superior also makes it practically problematic in ways American planners apparently haven't fully considered. Ritter's assessment, documented in classified reports that won't surface until Allied intelligence officers interview Luftwaffe personnel after the war, focuses on 3 critical vulnerabilities: manufacturing complexity, operational reliability, and the fundamental disconnect between theoretical precision and combat effectiveness. Each represents a different facet of the same basic problem. The Norden promises accuracy that combat conditions make nearly impossible to achieve. The manufacturing issue becomes apparent immediately when Ritter's engineers attempt to estimate production requirements. The Norden requires tolerances measured in thousandths of an inch. Components must be machined to specifications that demand specialized tools and skilled craftsmen. Assembly takes hours per unit, with extensive testing and calibration before any device can be approved for service. At the Norden Corporation facility in New York City, skilled workers, most of them German or Italian immigrants, hand-build virtually every component of the 2,000-part machine. Between 1932 and 1938, the company produced exactly 121 bomb sites per year. 121. Germany, by mid-1943, has already learned painful lessons about production bottlenecks and supply chain vulnerabilities. Strategic materials are increasingly scarce. Precision machining capacity is stretched across dozens of critical weapons programs. Skilled technical workers are being drafted into combat units faster than training programs can replace them. Building a device as complex as the Norden at scale would require diverting resources from tank production, fighter manufacturing, and artillery fabrication. Resources Germany simply doesn't have. The Zeiss Luftwaffe 7, by contrast, consists of a single metal casing containing most mechanisms, with a mirror tube extending through the aircraft fuselage. Simpler construction, fewer precision components, easier to manufacture in quantity. The Luftwaffe 7 works on similar principles to the Norden, using gyroscopic stabilization and tachometric calculation, but achieves comparable accuracy with dramatically less complexity. 3 large adjustment knobs instead of multiple fine controls. Single unit construction instead of separate stabilization platforms. Direct viewing of targets instead of the Norden's more elaborate optical system. Ritter's report to Luftwaffe Command emphasizes this manufacturing advantage. Germany can produce 10 Luftwaffe 7 units in the time it would take to build one Norden, maybe more. And in total war, quantity matters as much as theoretical quality. 10 adequate bomb sites equip 10 bombers. 1 perfect bomb site equips 1 bomber. The mathematics favor simplicity, but manufacturing considerations, while significant, aren't Ritter's primary concern. His real focus centers on operational reliability, how these devices actually perform when young men operate them under combat stress at extreme altitudes, while hostile fighters attack and anti-aircraft shells explode around their aircraft. The Norden's complexity, impressive in laboratory conditions, becomes a liability in combat environments. The stabilization platform, with its multiple gyroscopes and delicate adjustment mechanisms, is sensitive to vibration and temperature variations. Aircraft engines produce constant vibration. Temperature at 25,000 feet routinely drops to 50 degrees below 0 Fahrenheit. Ice forms on exposed surfaces. Electrical systems experience intermittent failures. The Norden's 2 separate assemblies, the stabilizer and the sighthead, must both function perfectly and remain precisely calibrated relative to each other. If either component fails, if calibration drifts, if electrical connections fail, the entire system becomes unreliable. American bomber crews, though Ritter doesn't yet know this in detail during mid-1943, are already experiencing exactly these problems. Maintenance records that will eventually be declassified show failure rates exceeding 50% on extended missions. Bombardiers learn to perform complicated adjustments mid-flight, trying to compensate for drift and mechanical problems. Some crews develop unauthorized workarounds, jury-rigging backup systems when official equipment fails. The gap between laboratory performance and combat reality is measured in hundreds of feet of accuracy, sometimes thousands. The Luftwaffe 7's simpler design proves more resistant to combat conditions. Fewer moving parts mean fewer failure points. Single-unit construction means no calibration drift between separate assemblies. The mirror-based optical system, while less sophisticated than the Norden's, functions reliably across wider temperature ranges. German bombardiers report consistent performance across missions, something American crews can't claim with their more complex equipment. But even perfect reliability wouldn't address Ritter's third and most fundamental concern: the disconnect between precision, capability, and combat effectiveness. The Norden promises accuracy within feet when used under ideal conditions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Clear weather, unlimited time on target, no defensive fire, stable aircraft, accurate wind measurements. These ideal conditions essentially never exist over defended German targets. Ever. Europe's weather is notoriously unpredictable. Cloud cover is constant. Visibility is limited. The clear blue skies American planners envision, where bombardiers can leisurely track targets through their sights and make fine adjustments before release, occur perhaps 10% of mission days. The rest of the time, bombardiers peer through clouds, squint through haze, or resort to radar bombing techniques that abandon precision entirely in favor of approximate targeting of entire city districts. German anti-aircraft defenses compound weather challenges. By June of 1943, Germany has positioned over 1,000 heavy flak batteries around strategic targets, 88mm guns, 105mm guns, even larger calibers for maximum altitude engagement. These weapons force American bombers to operate at 23,000 feet or higher, altitudes where the Norden's theoretical precision becomes practically meaningless. At 6 miles up, bombs take 60 seconds to fall, 60 seconds during which wind conditions change, aircraft movement introduces errors, and random atmospheric factors push projectiles off course. The Norden can calculate wind drift at bombing altitude, but wind at 25,000 feet bears no resemblance to wind at 15,000 feet, or 10,000, or ground level. The bomb tumbles through multiple atmospheric layers, each with different conditions. The mechanical computer can't account for variables it can't measure. Result bombs land anywhere within a circle 2,000 feet across. That's not precision. That's educated guessing with explosives attached. Ritter understands something American strategic bombing advocates apparently don't fully appreciate. Or perhaps they do appreciate it but can't acknowledge it without undermining their entire doctrinal foundation. Precision bombing from high altitude requires more than sophisticated bomb sights. It requires atmospheric conditions that permit sustained visual tracking, defensive situations that allow lengthy bomb runs without evasive maneuvering, time and stability that combat simply doesn't provide. The Norden is engineered for a version of warfare that exists primarily in planning documents, not over actual targets. German doctrine, shaped by combat experience in Spain during the 1930s and refined through early war campaigns, emphasizes different priorities. Dive bombing for tactical strikes, low-altitude attacks when precision matters, area bombardment when destroying entire industrial districts rather than specific buildings. The Luftwaffe learned that hitting exactly what you aim at matters less than hitting something valuable, and that surviving to bomb another day matters more than theoretical accuracy on any single mission. The Spanish Civil War provided laboratory conditions for testing bombing theories. The Condor Legion, German forces supporting Franco's nationalists, experimented with various techniques and aircraft types. Heinkel He 111s and Dornier Do 17s conducted horizontal bombing runs similar to what American planners envision for their flying fortresses. Junkers Ju 87s executed dive bombing attacks. The accuracy statistics were unambiguous. Stukas destroyed targets. Horizontal bombers scattered ordnance across landscapes. Technical data supported what combat crews experienced directly. A Stuka could place a bomb within 30 feet of an aim point, maybe closer. A horizontal bomber at altitude might land ordnance within 300 feet if conditions were favorable. More often, accuracy degraded to 500 feet or worse. Simple physics favors steep approach angles and lower release altitudes. The same physics that make the Norden's calculations so difficult at high altitude make dive bombing inherently more accurate regardless of bombsight sophistication. But Ritter knows Germany can't abandon horizontal bombing entirely. Dive bombing requires specialized aircraft. Stukas are vulnerable to modern fighters. Low-altitude attacks expose bombers to every caliber of defensive fire. Strategic targets deep in enemy territory, like Soviet factories beyond the Urals or British industrial centers, require bombers capable of long-range missions at altitudes that provide some protection. The Luftwaffe 7 serves that role adequately without the Norden's complexity and manufacturing challenges. Ritter's final report to Luftwaffe Command, submitted in late June 1943, recommends against adopting the Norden design or attempting to produce German copies. The Luftwaffe 7 provides comparable accuracy, simpler construction, better reliability, and easier maintenance. The resources required to tool up for Norden production would be better spent on fighter aircraft, anti-aircraft guns, and radar systems. Germany's defensive strategy should focus on making American precision bombing impossible through overwhelming fighter opposition and dense flak coverage, not on matching American bombsight technology. This decision, documented in Luftwaffe technical evaluations that remain classified until Allied intelligence teams discover them in captured German files after the war, represents one of the stranger ironies of the entire strategic bombing campaign. The Germans obtained complete details of America's most closely guarded bombing technology years before the first B-17 arrived in England. They built working prototypes, they conducted thorough technical analysis, and they concluded the device wasn't worth copying. Not because the Norden was bad technology, it wasn't. The engineering was genuinely impressive, but because sophisticated technology deployed under wrong assumptions produces disappointing results, regardless of engineering excellence. The Norden promised precision that combat conditions made unattainable. German analysts recognized this. American commanders, invested in billions of dollars and an entire strategic doctrine, apparently couldn't acknowledge it, or wouldn't acknowledge it. Meanwhile, the elaborate security protocols surrounding the Norden continue without interruption. Armed guards escort the devices to and from aircraft. Bombardiers take oaths, swearing to protect the technology with their lives if necessary. Storage vaults at bomber bases house the equipment between missions. Regulations specify destruction procedures if capture seems imminent. Shoot critical components with .45 caliber pistols. Use thermite grenades to melt everything into unidentifiable lumps of metal. The security measures remain in place even after hundreds of Norden-equipped bombers are shot down over German-occupied territory during 1943, making it obvious that Germany has had ample opportunity to examine captured examples. The disconnect between security protocols and reality becomes almost farcical. American military authorities insist the Norden remains secret, even while German engineers are studying both captured devices and the blueprints Hermann Lang provided before the war. The secrecy protects nothing except American public perception. Propaganda requires maintaining the fiction that American bombers possess technological superiority that justifies the casualties and costs of the strategic bombing campaign. Admitting that Germany has known the bombsight's secrets since 1938 would undermine that narrative. In July 1940, the FBI learned through counterintelligence operations that Hermann Lang had been ordered to return to Germany by the Abwehr, German military intelligence. He was arrested in June 1941. Court testimony revealed Lang provided drawings to a Nazi operative for $3,500. The blueprints were smuggled to Germany, starting in November 1937. Luftwaffe engineers built and tested a model. The FBI knew all of this by early 1941, 18 months before the first American bombers began operations from England. Yet the security theatre continues. General Henry Hap Arnold insists the Norden always be covered when being transported between storage and aircraft. Classification levels are adjusted downward as production expands, moving from secret to confidential to restricted, but the public narrative emphasizes that American bombardiers possess technology that provides decisive advantage. The reality, known to German intelligence and increasingly apparent to combat crews, is that the Norden provides marginal improvement over simpler bombsights under ideal conditions and essentially equivalent performance under typical combat conditions. The actual combat effectiveness of American strategic bombing during 1943 tells its own story, one that doesn't align well with the promises of precision technology. Statistics from 8th Air Force operations show that in the fall of 1944, only 7% of bombs dropped hit within 1,000 feet of their aiming point. 7%. Even by late 1944, after 2 years of combat experience and tactical refinements, only 41.5% of visually aimed bombs fell within 1,000 feet of targets. Using radar or radio aids instead of visual targeting, accuracy plummeted to 5%. These figures represent operational reality across hundreds of missions and thousands of bombing runs, not theoretical capability under laboratory conditions. not best-case scenarios with perfect weather and unlimited time on target. Actual combat performance by trained crews using the most sophisticated bombing technology available. The Norden, deployed under the conditions that actually exist over German-occupied Europe, achieves accuracy measured in hundreds of feet at best, and frequently thousands of feet. The disconnect between promised precision and achieved accuracy creates cascading problems throughout the strategic bombing campaign. American doctrine assumes that destroying specific targets, individual factories, particular transportation nodes, will cripple German war production. But hitting specific targets requires accuracy the Norden can't deliver under combat conditions. What actually happens is different, more brutal, and ultimately more effective than precision targeting ever could have been, though not for the reasons strategic bombing advocates imagined. German industry, unlike British or American manufacturing, uses dispersed production models that make precision targeting nearly impossible even with perfect bombsight accuracy. A single aircraft engine requires components from 30 different suppliers scattered throughout urban neighborhoods. Small machine shops occupy ground floors of residential buildings. Electronics assembly happens in converted warehouses. The entire production chain is woven throughout cities in ways that make distinguishing military targets from civilian structures effectively impossible from 25,000 feet. American bombs miss their precise aim points by hundreds or thousands of feet. But in densely built German industrial districts, bombs that miss the intended factory still hit something valuable. A bomb aimed at the Focke-Wulf aircraft plant that lands 3 blocks away might destroy a machine shop producing precision bearings. Another bomb, off target by 500 feet, might crater a rail line that supplies components to multiple facilities. Inaccuracy, paradoxically, increases effectiveness when the entire urban landscape contains war production infrastructure. The evolution of American bombing tactics reflects growing recognition that the Norden's precision capability matters less than simply overwhelming German defenses with massive tonnage. By late 1943, 8th Air Force conducts operations using 300 to 400 bombers simultaneously. By January 1944, formations exceed 700 aircraft. By February, 1,000 bomber raids become routine. These aren't precision strikes. They're saturation attacks designed to destroy entire industrial districts through sheer volume of high explosives and incendiaries. The lead bomber concept, developed to improve accuracy, actually acknowledges the Norden's limitations under combat conditions. Instead of every bombardier independently targeting through their individual bomb sites, entire formations release on signal from a single lead aircraft. The theory suggests that the most experienced bombardiers, flying in lead positions with the best equipment and most time to establish proper bombing runs, can achieve better accuracy than average crews. Everyone else just drops when the leader drops, hopefully placing bombs somewhere near the general target area. This technique improves results marginally. Formation bombing creates more concentrated impact areas than independent targeting would produce. But it also represents fundamental abandonment of precision bombing doctrine. When 300 aircraft release simultaneously based on one bombardier's calculations, you're not engaging in precision warfare. You're conducting area bombardment with extra steps and better public relations. The Norden's sophisticated mechanical computer becomes irrelevant when 299 out of 300 bombardiers aren't actually using it to make targeting calculations. The weather compounds every problem and exposes the Norden's fundamental unsuitability for European operations. Germany experiences cloud cover more than 50% of the time. Add smoke from defensive generators, industrial haze, and the simple fact that bombarding cities creates massive smoke plumes that obscure subsequent targeting, and visual bombing becomes impossible on most missions. The elaborate optical systems that make the Norden so expensive and complex can't see through clouds. American commanders adopt radar bombing techniques borrowed from the British. H-2X radar sets begin arriving in December 1943. Within 2 weeks, 8th Air Force authorizes area bombing of entire cities using radar targeting. Radar can identify urban areas through clouds and smoke. It can't discriminate between a ball-bearing factory and an apartment complex. Precision becomes impossible. Area bombardment becomes the default technique despite official insistence that American forces conduct only precision attacks on military targets. The statistics tell the story plainly. Radar-guided missions achieve 5% accuracy to 1,000-foot radius. 5%. The other 95% of bombs land somewhere else. Could be on valuable targets if the city contains enough industrial infrastructure, could be on residential districts, hospitals, schools, churches, whatever happens to be below, when gravity pulls ordnance downward through clouds and smoke. The secrecy surrounding the Norden persists, even as combat results make clear that the device isn't delivering promised capabilities. The disconnect becomes almost tragic when examining individual missions. October 14, 1943, Black Thursday, the raid on Schweinfurt ball-bearing factories. 60 B-17s are shot down, 600 crew members killed or captured, and post-war analysis shows that despite the enormous sacrifice, Schweinfurt's production recovered within months because precision targeting at altitude through defensive fire simply couldn't achieve the destruction planners anticipated. The Norden promised bombardiers could drop bombs into pickle barrels from 20,000 feet. Marketing genius. Public relations gold. Complete fiction. The device could theoretically achieve such accuracy under perfect conditions. Clear weather, stable aircraft, no defensive fire, unlimited time to establish bombing runs, accurate wind measurements throughout atmospheric layers, conditions that exist in test ranges and engineering laboratories, conditions that never ever exist over defended targets in wartime Europe. German analysts watching American bombing campaigns understand this disconnect. Luftwaffe intelligence reports throughout 1943 and 44 note, with interest, that American doctrine emphasizes precision, while American practice increasingly resembles British area bombing. The Germans adapt defensive tactics accordingly. If Americans are going to scatter ordnance across entire urban districts, regardless of official targeting doctrine, then defenses should focus on forcing bombers higher, disrupting formations, and creating conditions that maximize inaccuracy rather than trying to defend specific factory sites. The flak batteries positioned around major German cities are calibrated for high-altitude engagement, 88mm guns, 105mm weapons, even larger calibers. These aren't designed to hit every aircraft. They're designed to force bomber formations above 25,000 feet, altitudes where accuracy becomes nearly impossible regardless of bombsight sophistication. German fighter tactics evolve similarly. Attack bombers on approach to targets, disrupting formation integrity and bombing runs. Force evasive maneuvering that makes steady flight impossible. The Norden requires stable aircraft for its calculations to work. Defensive fire ensures aircraft are never stable during the critical minutes before bomb release. The entire defensive strategy aims at exploiting the gap between the Norden's theoretical capabilities and its practical performance. German planners recognize what American commanders apparently can't publicly acknowledge. Under actual combat conditions, sophisticated bomb sites provide minimal advantage over simpler systems. The limiting factor isn't calculation precision, it's atmospheric variability, defensive disruption, and the simple physics of dropping explosives through 6 miles of turbulent air. The irony becomes almost painful when considering development costs. America spent $1.1 billion on the Norden program. Research, development, production, distribution, training, maintenance infrastructure. $1.1 billion in 1940s dollars, roughly equivalent to 2/3 of the Manhattan Project budget, more than the entire B-17 bomber program. And combat results show that simpler British bomb sites achieve equivalent accuracy under operational conditions at a fraction of the cost. The British stabilized automatic bomb sight works on similar principles but with reduced complexity. The Germans, as Oberst Ritter's evaluation concluded, do fine with the Luftwaffe 7. Even the Japanese, capturing Norden examples from downed B-25 bombers, decide the device is too complex for mass production and develop simplified versions instead. Everyone who examines the Norden reaches similar conclusions. Impressive engineering, questionable practicality, not worth the resources required to replicate. But American investment in the Norden goes beyond financial costs. The entire daylight precision bombing doctrine rests on the premise that sophisticated technology enables precision strikes impossible with less advanced equipment. Admitting the Norden doesn't deliver promised capability means admitting the whole strategic approach requires reconsideration. The organizational and psychological investment makes honest assessment nearly impossible. Too many careers depend on the fiction. Too many deaths need justification. The truth becomes unsayable. The security protocols serve this psychological need as much as any legitimate operational requirement. Treating the Norden as ultra-secret technology maintains the narrative that American bombers possess decisive technical advantage. Bombardiers taking oaths to protect the device with their lives if necessary aren't protecting actual secrets. Germany has known everything about the Norden since 1938. They're protecting American self-perception, the belief that technological superiority compensates for the horrific casualties and limited accuracy of strategic bombing. When the war ends in Europe during May 1945, American intelligence officers interrogating Luftwaffe personnel receive a shock that should have been predictable. The Germans knew about the Norden before the war started. They built prototypes, they evaluated the technology thoroughly, and they decided it wasn't worth using. Not because German engineers couldn't understand American innovations, but because German analysts recognized that complex technology deployed under flawed assumptions produces disappointing results regardless of engineering brilliance. The captured Luftwaffe evaluation reports make fascinating reading. Clinical assessments by engineers who respect American technical capabilities while questioning strategic judgment. The Norden is acknowledged as sophisticated, well-designed, impressively engineered, and also as unnecessarily complex for the missions American bombers actually fly. The simpler Luftwaffe 7 achieves comparable results with better reliability and easier production. German analysts prove correct about combat effectiveness, while American doctrine insists on theoretical superiority. The post-war United States Strategic Bombing Survey attempts comprehensive analysis of the entire strategic bombing campaign. Thousands of pages examining industrial damage, production statistics, casualty figures, resource allocation. The conclusions about bombing accuracy are damning when read carefully. Precision bombing, as practiced by American forces throughout the war, achieved accuracy measured in hundreds or thousands of feet, not tens of feet, not the pickle barrel mythology, not the precision that justified billion-dollar investments in bombsight technology. By 1945, 8th Air Force is placing up to 60% of bombs within 1,000 feet of aiming points under visual conditions. 60%, that's the success rate after 3 years of combat experience, tactical refinements, improved crew training, and reduced German defensive capability. Even at the end of the war, with Luftwaffe fighter opposition largely eliminated and flak batteries depleted of ammunition, American strategic bombing achieves accuracy that would be considered barely adequate for area bombardment, nowhere near the precision theoretically possible with Norden equipment. The survey's conclusions about strategic bombing's effectiveness focus primarily on disruption of German transportation networks, oil production, and overall industrial capacity, rather than destruction of specific facilities through precision targeting. The reality is that American bombers won through overwhelming tonnage delivered against entire industrial regions, not through precision strikes on individual factories. The Norden contributed to this success only insofar as it helped bombardiers aim approximately at target areas before releasing bombs that would scatter across several city blocks regardless of exact aim point. The human cost of maintaining the precision bombing fiction includes not just combat casualties, but also the civilian deaths that result from bombs missing their precise targets. Official American doctrine throughout the war insists that bombers target only military objectives. Factories, rail yards, oil refineries, military installations. The Norden supposedly enables such discrimination. Reality is different and more brutal. When bombs miss targets by hundreds or thousands of feet, and targets are located in urban areas surrounded by residential districts, civilian casualties are inevitable, regardless of intent or official policy. German cities sustain enormous civilian casualties from American bombing, not because American crews deliberately target civilians, but because precision targeting proves impossible under combat conditions and bombs aimed at military targets land everywhere within large impact areas. The distinction between precision strikes on war industry and area bombardment of cities becomes academic when ordnance scatters across entire districts. The Norden promises discrimination, the physics of high-altitude bombing make unachievable. The legacy of the Norden Bombsight extends far beyond its actual combat effectiveness. It becomes symbolic of American belief in technological solutions to warfare's fundamental problems. The faith that superior engineering can provide decisive advantage. That precision weapons enable more humane warfare by limiting collateral damage. That sophisticated technology, deployed by well-trained personnel, will produce results proportional to investment and sacrifice. These beliefs shape American military doctrine for decades after World War II, through Korea, Vietnam, and into the precision-guided weapons revolution of later decades. But the Norden also demonstrates the limits of technology when deployed under flawed assumptions. No amount of engineering sophistication can overcome atmospheric physics, defensive disruption, and the chaotic reality of combat operations. Precision requires conditions that warfare rarely provides. The gap between laboratory performance and battlefield effectiveness represents one of military planning's enduring challenges, one the Norden experience illustrates with brutal clarity. Hermann Lang, the spy who provided Germany with complete Norden plans, is sentenced to 18 years in prison on espionage charges after his conviction in 1941. He serves his time at Federal Penitentiary, part of the largest espionage prosecution in United States history. The Duquesne spy ring's destruction represents major counterintelligence success. But Lang's espionage made no difference to German military capability. The information he provided was interesting to German engineers, useful for understanding American capabilities, and ultimately judged insufficient reason to abandon existing systems that work adequately at lower cost and complexity. Oberst Nikolaus Ritter, the Abwehr officer who received Lang's intelligence and supervised the evaluation of stolen Norden plans, survives the war. His reports on American bombing technology prove accurate. The Norden is sophisticated but impractical for German needs. Resources are better spent on defensive weapons and fighter aircraft. His assessment, controversial when submitted, appears prescient when examined decades later with access to complete combat records from both sides. The billions spent on Norden development and production bought America a bombsight that worked adequately under combat conditions, not exceptionally, not with the precision promised by manufacturers and demanded by doctrine. Adequately, comparable results to simpler British and German systems at dramatically higher cost and complexity. The massive security apparatus protecting Norden secrets safeguarded technology that enemies had already obtained and evaluated and judged not worth copying. The elaborate training programs for bombardiers taught techniques that combat conditions made impractical. What actually won the strategic bombing campaign was not precision, but persistence, not sophisticated technology, but overwhelming numbers. Not the Norden's mechanical genius, but the production capacity that put thousands of bombers into the air, carrying hundreds of thousands of tons of ordnance. American industrial might, not American bombsight design, destroyed German capacity to continue fighting. The Norden contributed to that effort, but not in ways its designers or advocates anticipated. The final irony cuts deepest. Germany knew everything about the Norden years before it became operational. They studied it, tested it, analyzed it thoroughly, and they concluded Americans had engineered a brilliant solution to the wrong problem. Precision from high altitude under combat conditions is effectively impossible, regardless of bombsight sophistication. Better to design for adequacy under realistic conditions than theoretical perfection under ideal circumstances that never occur. German analysts understood this. American planners, despite mounting evidence from combat operations, never fully accepted it during the war. Today, when historians examine World War II's strategic bombing campaigns, The Norden represents a case study in the gap between technological promise and operational reality. Museums display the devices with plaques describing their sophistication and complexity. Aviation enthusiasts admire the engineering that went into their design, but honest assessment must acknowledge that the Norden's impact on the war came primarily from the psychological comfort it provided to crews and commanders, rather than measurable improvement in bombing accuracy. The crews who flew through German flak and fighter opposition deserved every technical advantage available. If they believed the Norden gave them better chance of survival and mission success, if that confidence helped them face impossible odds mission after mission, then the device served purpose regardless of actual performance statistics. But we should not confuse operational mythology with technical reality. The Norden did not enable precision bombing from high altitude under combat conditions. Nothing could have enabled it given the physics involved and defensive responses available to determined opponents. The story of the Norden reminds us that warfare is ultimately about solving practical problems under terrible conditions, rather than achieving theoretical perfection under controlled circumstances. The most sophisticated technology means little if deployed under assumptions divorced from reality. Sometimes adequate equipment used intelligently produces better results than perfect equipment applied to impossible tasks. German analysts understood this when they examined stolen Norden plans in 1938. American commanders eventually learned it through brutal experience over German cities during 3 years of costly operations. The legacy endures in modern military planning, the tension between precision capability and combat effectiveness. The challenge of achieving accuracy under defensive fire and atmospheric interference. The recognition that technology alone cannot eliminate war's fundamental chaos and uncertainty. These lessons, purchased at tremendous cost during World War II, remain relevant to contemporary conflicts, where precision-guided weapons promise discrimination that real-world conditions sometimes make unachievable. The Norden story, properly understood, cautions against technological optimism, disconnected from operational reality. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.